please. Now what we want to do is to tell you that petrol fumes are very dangerous. They can start the fire. So is any flammable organic liquid. Say for example, what is this? What does it smell like? Take out your this, yeah.
Cologne.
Sounds like cologne, right? This one is desire. Desire. Okay. And this cologne has actually alcohol inside here. And the fragrant material, say from anything, maybe flowers or certain fragrant solid that can be made into a perfume, will be dissolved in the alcohol. So this is dangerous in the sense that although you spray like that, okay. You spray can be dangerous because if I have a flame, now I have a flame, slow motion, okay. If I have flame and I spray, I can get something like that. I can get a flame like, okay. You can stop your this. Yeah, you can stop that enough. So is this. This is pure alcohol, or alcohol with water. Even alcohol with water, you spray, it can also start a fire. Now actually I wanted to rig up a powder spray. If I spray a powder, any flour, the baking flour, I spray, it will also burn. That's very strange, but that one is another issue altogether. So you can see that this is a flammable liquid. Okay. Now this one is a balloon. Okay, this is a balloon. Then I'm going to light a candle here. Light a candle and put it here. Light a candle. Okay. And of course this one I spray on the candle. It will also give you fire like that. Now, if I were to blow the balloon, can you blow? Hard. Blow the balloon. Okay. You're not strong enough. Okay. What do you think will happen if I put this balloon over the flame? What do you think will happen?
It'll burst.
You think it will burst? Put it over the flame. Come on. Near?
Yeah.
Of course it will burst, huh? Yeah. But this is a balloon filled with water. Okay? Now we are going to put that near and see whether it will burst or not. Okay, put it near. Put it near. Put it nearer. Put it nearer. Put it put it nearer. Okay, enough. It won't burst, right? So it just gets dirty. This is the carbon from the candle. The candle is actually, candle wax is actually a hydrocarbon. What is hydrocarbon? A compound that contains only hydrocarbon,
hydrogen and carbon.
So you can see that it burns combine with oxygen. Not all the carbon combine with oxygen. Some combine with oxygen to give carbon monoxide, which is poisonous. Some combine with oxygen to give carbon dioxide. And the hydrogen inside there, inside the candle wax, will be converted into water vapor. But this doesn't burst because it has got water inside. And water is able to absorb all the heat into itself. It takes a lot of heat to boil water. And it takes a lot of heat to have a hot bath in a bathtub. Okay, a lot of heat. We will learn exactly how much heat is required later on in the thermal physics section. So when the heat is pulled away from the rubber balloon bursts because it has reached its ignition point. Ignition point for a alcohol vapor is very low. Ignition point for a balloon rubber is probably 100 degrees centigrade. So for anything to ignite, you must reach its ignition point. Ignition, not point, temperature. Ignition temperature. Okay? So when I heat this, the heat gets absorbed by the water, and it keeps being absorbed by the water, and the temperature, ignition temperature, is never reached. So if it is never reached, it will not burst. Okay? Now give me a strand of your hair.
Just one.
You got long hair, right? Can you pull a strand? Pull 2 strands.
Okay, let me
Pull
try.
2 strands. Pull, quickly pull.
What is it?
Ow.
Ah,
Just one.
okay.
Two strands. Pull. Let me get some telephone tape. Got?
Yeah, I got one.
Oh, okay.
Okay,
got
got
one.
2.
Okay, one strand is here. Never mind. Or two already, or 2. Now what we are going to do is, one of them, we are going to wind over here. Wind over here, wind over the metal. Okay? And of course I will have to put a cellophane tape onto here. Put cellophane tape onto here, and then I wind like this. Wind very tightly. Okay, this I think is tight enough. Okay, it's tight enough. And I will use a cellophane tape to tape. Okay, so can you see the hair there?
Yeah.
Yeah. Now if this hair were to be held over the candle, what do you think will happen? The hair will burn. But what's that name starting with S? The hair singe. Singe is spelled as sing with an E. Singe. Okay? The hair singe, right?
Yeah.
Can you see the hair? Oh wow, okay. The hair will singe. Because it has, why your hair so strong? Yeah, it will singe. The hair will singe, okay? See, yeah. But if I were to heat this portion, tight closely to the metal, this portion, do you think it will singe?
No.
No, it will not singe. Can you see it's still there?
Yeah.
Yeah. So how do I explain this?
The metal absorbs the heat.
The metal has it's a good heat conductor. You will conduct the heat away from the hair, and the hair will not reach its ignition temperature, and therefore it will not singe. But if the hair is not tied to the metal like this portion, then it will singe like that. Can you see? It will singe, right? So is this portion. This one will singe. Well, your hair is quite strong at some places. Okay. Yeah. Can you see it singes? Okay. And of course, this is our play toy. This is our play toy where we have used before, but since it's out here, we will play again.
Only one.
Only one. Okay. Yay! This is resonance, as far as that is concerned. Okay, you play while I play. Okay. Let me clean this. Turn it sideways and turn it sideways. Okay, you play with it while I go and get some ice, okay? Keep playing with it. Play it sideways. Play that from home. Okay. Do it sideways to the camera. Yay! Yay! Resonance of energy, right? Now here we have some ice cube. Okay, I'm going to put an ice cube on this metal, and I'm going to put an ice cube on the plastic. And let's see this. Can you see that this one is melting so fast? Huh? This one is melting so very fast. Let's take this one now. Turn it over. And this one is melting so very fast. Can you see?
Yeah.
And this one is melting so slowly. So the question is, why is this melting so fast while this is melting slowly? Why do you think?
Metal is a good conductor of heat.
Metal is a good conductor of heat, okay? So it is absorbing heat from the atmosphere and transfer it along the metal to melt the ice. While this plastic table is not a good conductor of heat, therefore it doesn't pull the heat from the air, from the atmosphere, so it's melting very slowly. Okay? Now feel this. Is it cold?
Yeah.
Of course it's very cold, because heat is pulled away from the metal, and this is called a miracle tool. It's a special metal that is able to conduct heat very quickly, and we call that a low specific heat capacity. And we will learn about heat capacity and specific heat capacity in our thermal physics. Can you see this is almost melting? Wow, look at it. Look at it. Yay!
Yay.
Yeah. Yeah. Touch, is it cold? It's very cold, right? Oh? This part is very cold. Touch.
Yeah.
Yeah, very, very cold. Of course, as you go further away, it becomes warmer. Can you see? Touch. Yeah. Here, cold, right? Here, very cold, right? Here, become warmer. Now, what do you think this can be used for? What do you think it can be used for? I bought this when I was at the exhibition, and they were trying to sell housewife this metal.
Okay.
It's called a miracle tool. So if I were to put a cold frozen slab of meat onto here, it can thaw very easily, right? Okay, that's one. Where heat is pulled from the surrounding through the metal onto the frozen slab of meat. What about a cup of hot tea on a metal cup? If I put on here, what do you think will happen? The reverse way, right? So the cup of hot tea, or the hot tea inside the metal cup, the heat will be lost to the surrounding the reverse way. So you could cool a cup of hot tea in a metal cup very easily, and it can thaw or warm up a slab of meat, frozen meat, also very easily. So when you talk about science, you try to have a two-way or the converse of one direction, what happened the other direction. Like the heat can be pulled from the surrounding to the ice or to the cold slab of meat, or the heat can be pulled away from the hot tea in the metal cup to the surrounding. That's cooling the hot tea. This is warming the cold ice. Yeah, thank you. Touch, very cold now. Okay, one more thing before we conclude that. If I were to press these two together, what do you think will happen?
Slipping.
Huh?
Ah.
If I press these together, what do you think will happen? And then I let go,
Oh.
they get stuck together. Yeah, that is another story altogether, okay? That's another story, which we will tell our story to you who sees the YouTube. Bye! Bye! Yeah, this is Christine.